This is part 1 of our lesson on refraction of light. Refraction is defined as the change in velocity of light as it travels through different media. The speed of light in vacuum or in air, denoted as the small letter c, is equal to 3.00 times 10 to the 8 meters per second. The speed of light in any other transparent medium is less than that. All material media, transparent media, have a property called the index of refraction n. And the definition of the index of refraction of a material is the ratio of the speed of light in vacuum, c, and the speed of light in that material, v. Now in this ratio, because c is greater than v, then n is always greater than 1, which means that the index of refraction of any medium is greater than 1. Well, the index of refraction is also dependent on the frequency of light or the frequency of radiation. In this case, we're only going to consider the refraction of visible light, which is white light. Now let us look at this figure and let us use the laws of refraction in determining how this light ray will be refracted. So we have here two different media. So we have medium 1, we're going to call it medium 1, and the index of refraction is N1. And medium 2, the index of refraction is N2. Now we have a light ray. Suppose we have a light ray traveling in medium 1 and it enters medium 2 at this point. And this right here is the original path of this incident ray. Now at the point of incidence, we have I have drawn the normal line, which is perpendicular to the boundary, so that we can indicate the angle between the incident ray and the normal, this angle right here, and let's call it theta sub 1, which is the angle of incidence. Now the question is, how will the light ray be refracted, or how will it bend when it enters medium 2? It could bend closer to the normal like this, or it could bend farther away from the normal like this. Well, it depends on which of the two media has a higher index of refraction. Now let us consider, let us say that in this case, that N2 is greater than N1. So the light ray is refracted like this. So this is the refracted ray. And we can also indicate the angle between the refracted ray and the normal. We call that the angle of refraction, theta sub 2. Now the angle of incidence, the angle of refraction, the index of refraction of medium 1, and the index of refraction of medium 2 are related by the law of refraction known as Snell's law, proposed by Wilbur Snell, a Dutch astronomer and physicist, in 1621. He said that the ratio of the signs of the angles of incidence and refraction, so let's write that down, sine angle 1 divided by sine angle 2. So the ratio of the sines of the angles of incidence and refraction is equal to the inverse ratio of the indices of refraction. So this is N2 over N1. Now this law can be used to trace the path taken by any light ray as it travels through different media. Now, the right side of this equation is the ratio of two constants, which means that this is a constant. And of course, if the ratio is a constant, it indicates a direct proportionality. So therefore, we can say that because the ratio of sine angle 1 and sine angle 2 is constant, then we can say that sine angle 1 is directly proportional to sine angle 2. Now this means that if angle 1 increases, angle 2 increases as well. So that means that if you change the value of angle 1, or if you increase angle 1, then angle 2 will also increase. Now, Snell's law can also be written as N1 sine angle 1 is equal to N2 sine angle 2. And if there's a third medium, then that's equal to N3 sine angle 3. Which means that the product of N and sine of the angle is also a constant. And if the product is a constant, then that indicates an inverse relation. And in this case, it means that N is inversely related to the sine of the angle, which translates to if N2 is greater than N1, then angle 2 is less than angle 1. As we can see here, because N2 is greater than N1, then angle 2 is less than angle 1, and vice versa. Now, we will be using Snell's law in computing problems or in solving problems on refraction, and also in the next video, which is about total internal reflection and the critical angle. As a trivia, the index of refraction of different materials vary, of course, and for transparent materials, the one with the highest index of refraction for visible light is diamond, with an index of refraction of 2.42. See you in the next video.